Hello campers, Dr. Dickey here. And the big dig begins. Obviously I'm not going to have you sit there and watch me dig everything. That would be boring. I will bring you in when I have portions of it done to show you the progress as we go along. Well, that wasn't too bad. I've got it dug basically out to the turn there before it makes the long venture down to the air conditioning unit. And I want to get that dug out, then I'm going to pull this all up out of the ground. I will probably cut it off where it goes into the shed, pull this up and just kind of move it aside. One thing that I have to do, that I didn't do last time obviously, is I think it's the NEC, the National Electrical Council or whatever. They call for 18 inches below grade for even conduit. Obviously I did not put this at 18 inches below grade. It's like 6 inches in some places and maybe 12 inches in a few others, but not 18. So I will make sure this time that it's all 18 inches, and I'll show you that before I bury it. I also got tape that says electrical below, and I'm going to put that on top of this when I fill it back in, so that if anyone digs along here, they will hit that tape and realize there's an electrical conduit down there. I don't even need the conduit. I have UL approved 3-conductor in a ground, which means I could bury it without conduit. But I just feel better if it's in a conduit. More work, yes, but just makes me feel better, so that's what I'm going to do. All right, so I'll bring you back in when I get the next section dug and show it to you. Don't have it done. Got about a little over 2/3 maybe. Not quite 2/3. Now where I'm running the trench here, the long trench, I'm taking that down to at least 20 inches, 21 inches. And the reason for that is NEC code says the pipe has to be at least 18. Well, because I'm digging this trench just to the east of the old pipe's not in my way, I can dig it down. And I want verification that I am digging it down to depth. So I'll show you the head on that shovel is 17 inches. So let me show you that. And I want proof I'm going down about 22 inches. So that when I put the pipe in, I'll measure it again, and I'll hand dig anything that has to go down maybe a ½ inch. But I'm going to make sure this pipe is, the top of the pipe is greater than 18 inches below the grade. Okay, let's look at that and I'll show you. I'm not sure if you can see that on a shovel, but like I said, the head up to here is 17 inches. So, and that's at least 5 inches below. So if we go down here like this, I go down here like this, you can see that's 24 inches to up here. From here down to there is 24 inches. It's right on that 2 foot 24 inch mark. So I'm down 24 inches in most places. Now right now I don't have it done everywhere else because if you look at the pipe, you can see the pipe is in the trench for most places, so I can't dig it out until I take the pipe out. But here, because I am putting it in just to the east because it was too close to the walkway and it was collapsing down some of my siding that I put in. So this time I'm moving it just a little bit to the east, and so I can dig that trench. So when I get this finished, I'm going to put us back on the grid, take us off the solar, take the Sawzall, cut this stuff out and take it out. Then I just have to finish trenching the small portions down to 21 inches. And then the hope is to get the wire run today into the garage, at least into the garage. So that's what we're shooting for. Well, as you can see, everything's been installed. That's the power going in. Now with 2 hots, a neutral and a ground, so split phase. Everything's been buried. I just got to replace the pavers along there and rake it all out and re-rake the lava rocks back over top of it, and then pretty much reconstruct everything back here. I have to reconstruct everything that's been taken apart and fix this up, and then I'm going to build a pathway through here so that I can walk on stones along here rather than walking on the dirt back into the shed. And there, of course, is where it goes into the shed. Not as neat as it was before, with the now split phase, but oh, that's all right. Still goes in. I left the wires extra long going into, and I got to clean this place up. I left the wires extra long going into the breaker for the old inverter, because I don't know exactly how the new inverter is going to be hooked up. This, of course, is the new hot that's unused, just using the one hot and the neutral there. So that'll be the next thing, getting the new inverter in, which is about $1,200–1,500, and then I can add in those other circuits and move some circuits around to balance things out, because I don't want to have 90% of it on one leg and 10% on the other leg. So I'll do a video about that, hooking up the new inverter and hooking up the new circuits for the different portions of the house. Like I say, be adding my bathroom, my wife's bathroom, and the garage. My bathroom is on the same circuit as the washing machine. Hers has a heater, but she never uses it, so that'll be okay. I don't think that'll be a problem. She never uses that heater that's in there. I need to give an update. I videotaped a lot of things, and then the camera fell down, and what I videotaped was lost. Solar array's working good. I have the big dig happened and has been buried back up. I've got the new 3-conductor in the ground going from the solar shed into the garage. I got to do a little cleanup. Needs to rain more to clear up stuff before I do a final, and that's where it goes in now. So everything's been buried up. It's actually been raining too much, that's why I haven't done a video. So again, big dig done, close back up, most everything put back. I've got to build a pathway along here to the shed. The shed is a mess, but I just wanted to show you a few things since we actually have a little sun today. I got to clean up a ton of stuff in here, but the new inverter is in. It is enormous. This thing is 72 pounds. Fortunately, my neighbor helped me get that back up into the cabinet. But it's all up in there, and I'm running all of the house is being run off the inverter except for the 240 systems. That is heating or air conditioning, oven, heater, hot water heater. Other than that, pretty much the entire house is being run off solar, which is great. One thing was, I got these individual circuit breakers. I've got to fix that wiring up a little bit. I wanted to put extra length wires on it, so I had the ability to move it wherever it was. But I bought these circuit breakers because I wanted an individual circuit breaker for the 2 different hots and the neutral. And these circuit breakers come where it goes in, the load goes in the bottom and the line goes out the top. I've never seen a circuit breaker like that. All the ones I've ever seen, line goes in the bottom, load goes out the top. But not on this one. So I had to put them in such a way that you have to flip the switch down for it to be on and up to be off. So I've got some replacement ones for that because that just bothers me. I did get the negative wire from the inverter, from the solar charge controller. The PV coming in now goes through the breaker and goes into the Midnight Classic. So that is protected. That's oh, get that back on here. So that's all wired up, that's all working. So one thing is these drawers in this cabinet. I bought this cheap cabinet from Walmart to be able to put stuff in, and right now the battery that's running the fan is sitting on top of it, and that worked really good, except the things I was putting in there were so heavy, like this wire, these wires things are just so heavy that they broke out the bottom of all the drawers. I should have known that was going to happen. So like I said, right now I got a ton of stuff just thrown in the bottom of the cabinet here. So to help with that, I bought this tool chest, and I'll be able to store a lot of the heavy stuff down in the bottom of this tool chest and then put tools and other heavy things over here. And I'll keep the cabinets. I'll have to fix the drawers up and get them back in working order. And I'll keep that, and I'll use that for other things that aren't as heavy. So that really is the major announcements. Like I said, we've got all of the house except for the 240 systems are the only one. I think there's one plug, one of the 8 plugs in the kitchen is not on the solar system, only because I have 10 circuit breakers on the solar system is all I have. And so, if I had 12, I think I could do 100% of everything but the 240. So there's like one plug that we don't use very often in the kitchen that isn't on the solar system, and I think the light in my wife's bathroom, and it's just like a light bulb. A light bulb in her vanity area, that's all on the solar system, but there's the light bulb in her bathroom is not on the solar system, so that's like one light bulb, which only gets turned on when it's night and she goes to the bathroom and blah, 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 so it's not really consuming much power. So basically, almost all the power except for the 240 volt systems are on the solar system. And I think I said last video that the first electric bill we got that was with the solar system on all the time went from 996 kilowatt hours down to 426 kilowatt hours. So a greater than 50% reduction in the amount of electricity used off the grid, which I was very, very happy about. So that's the latest. What I have to do now is just a bunch of cleanup and then maintaining the system, and I'm still working on building the addition to these packs, which will come with an additional 80 cells. It'll be in something about this length. It'll be an additional 80 like that. It'll be additional 80 cells per pack. Right now each pack has 160 cells, so it will be half again as much. And I'll just have the bus bars come up and just bolt right onto there, and I'll put the 14 packs just on top of these 14 packs to piggyback them and increase my capacity again by half again, and that should help. Right now, even so, with everything on the system, the individual cells overnight before the sun comes up, or if it's a really even if it's a really cloudy day, the solar system generally puts out enough power to recharge the batteries, as long as it's not really hard, cloudy, and rainy. If we have some sun, like we're going to have some today and for the next several days, a couple hours of sun is all we need to charge everything back up. Overnight, the cells go from their full charge for what I have here is about 4.02 volts, and they go down to about 3.8 something volts overnight, which is very minimal dipping into the capacity of the packs. But of course, I want to be able to do that even better. I want even a smaller dip, and want the ability to not have to worry about whether we're going to have 3 or 4 really cloudy days in a row that may stress the packs out a little bit. So that's where we stand right now. What else do I need to do? Again, besides just cleaning up stuff in here, just maintenance, and continue to work on increasing the capacity of the battery. Anyway, thanks for watching, and I'll have something else coming up in a little bit when I get to it. All right? Have a good one. Bye-bye.